Okay, all right, everyone. This is lecture 4 of this course on Introduction to Computer Science and Programming in Python. Last time we discussed while loops and for loops, the differences and similarities between them. And the purpose for using these loops in our program is to iterate over elements or do some operations more than one times. And by now you should know how to write both of these and when to use which one. In the second part of our last lecture, we also looked at some important algorithms. Two of them were the guess and check and approximation methods. But both of these took a lot of operations to find our answer based on what problem we were trying to solve. And the last one that we looked at was the bisection method for searching a specific number within a range. And you saw that the gain of complexity time or gain of runtime was considerably higher. Something which was taking about 20,000 iterations here was done within about 14, 15 iterations in the bisection method. So what we will talk about today is adding some structure to the programming method that we do and how to hide details behind abstraction. And the way to do that is to use something called functions. And we will talk about what are the function specifications and what's the purpose of return statement within a function and how do the return and print statement differ from each other. And when we talk about functions, we also need to understand the concept of scope of variables within our overall program when there are more than one functions involved. So far, we have covered some basic mechanism about the Python language. We have talked about some data types. We have talked about the for and while loops and all the programming that we have done so far, we have been doing it in one file. So a sequence of statements, expressions, written one after the other, whether they include a loop or not, they are all situated in one file and they all run sequentially. So each file is a collection of some statements, some piece of code, and that's how we run our programs. But for small scale problems, it is okay. But as our problems and algorithms become larger, this programming approach of writing everything in one file without creating some reusable pieces of code, it becomes messy very soon as programs become larger. So and it becomes hard to keep track of where everything was. And if we, for example, create a for loop, which is very similar in use, and we have to write it 5 times in our program in multiple places, and then we find out there was a problem in it. So we have to find all of those places to fix it. This concept of decomposition of code into more than one functions and then using abstraction of not knowing how the function works, but using it by just reading its specifications. That's what we will talk about today. Okay. When we talk about good programming, it's not necessary that when you write a lot of code, it's a good thing. No, that doesn't matter. What matters is the kind and amount of functionality that your code provides, no matter how long or short it is. So that's where we will talk about functions and how to use them multiple times within our programs. And functions are a way to to decompose our code and then encapsulate it into one piece of code that can be moved around or called more than once. And this is also how we achieve abstraction of one programmer might write a function and then provide some specifications as a doc string on top of it. And the other programmer just calls that function, does not need to know how that problem within the function is solved, but just wants to use it, and the other programmer can do it. And that concept is called abstraction. So let's say there is a projector that we use usually in in-person classrooms. So it's a complicated piece of machinery, and but not everyone who is using that projector does not know how this works inside. It's a black box for them. What they do is they plug it in into a power outlet, and then they provide it some file to be displayed on a large screen on the wall or on the board. And that's all they need to know. They just have to do these few simple actions to be able to use the projector. They don't need to know how it was originally created and built inside, right? So that's the concept of abstraction, and that's exactly what we do in programming, is that we create a functionality, we encapsulate it in a function, and then other people can use it by reading what we wrote as a specification, that what is the input to this function and what output can you expect. And at the same time, there could be, for example, in the Olympics or other large arenas, there may be more than one projectors which are working together to project a larger image somewhere, either on the stage or on the wall. And that's the concept of decomposition. So there may be 100 similar projectors which are getting different types of input and projecting it out, but overall together they create something which makes something meaningful, which makes the overall image meaningful. So that's the concept of decomposition. And in our programs as well, we write a lot of functions, and even one function is being called again and again. But the overall result of all of that computation is something which makes sense to create the final result that we are looking at. So this concept of abstraction and decomposition in programming is important, and this example of projector is one way to understand that. So let's see how this concept of decomposition and abstraction is applied to programming. What we will see is how to organize our code into modules. Okay, and we will talk about functions in the beginning, and later on in some future session we will also talk about classes. So what are these modules? They're self-contained pieces of code that work by itself and does some sort of complete processing or computation. It gets some input and provides some possibly provides some output or does some operations on a piece of data type, right? So it's a way to break up code into smaller pieces. It is always a good practice to keep functions in a manageable length or lines of code. So that you can go through them, find issues, you can write them as well easily, and debug them easily as well. So they keep your code organized and they keep your code coherent. So in this session, we will talk about functions, not classes. We will talk about classes in another session later on. Going back to the projector example, the instructions of how to use it are sufficient for us to be able to use it properly. We don't need to build one every time, or we do not need to know how to build a projector to be able to use it. So in programming as well, we think of a piece of code as a black box. We cannot see the details inside. We can, but we don't have to. And we don't have to, and we don't want to see. And we don't want to know how tedious the code inside is. But what we want to know is what this function does. And the way to do that is by using doc strings. That's the multiple lines of code in the beginning of a function. We will take a look at an example in a minute. And using that specification, we would know how many parameters or arguments it is expecting and what kind of output it will give us. Okay. So the concept of using the function is that it is written by a programmer, and then they specify what it does. And then they do the actual programming, which is inside it. Okay, and for either they themselves or some other programmer will call or invoke this function in their program and use it. So what's part of a function? It has a name, of course, so that we can call it. It has some parameters, some data elements that we pass to it. It's possible that there are no data arguments for a function. If it does something on its own, that's possible as well. But there could be 0 or more parameters which are being passed to a function. Docstring is a very good programming practice that whenever you write a new function, you should write in the beginning of it, you give some specifications of what it does. It includes at least the information about how many and what data types of parameters it is expecting and what it will return. And then optionally, you can add how it is doing its implementation on a very high level. And then it has a body, which is the actual code of the function. And lastly, it returns something. And also, it's possible that you don't return anything. If you do not have a return statement within a function, it would automatically, Python will return the none type data type with a value of none that would be returned back to the program which called or invoked it. Okay, so here is a simple example of a function which is checking whether a number is even or not. Okay, and all the elements are identified here. Def is a keyword which lets Python know that you're about to define a function, then you give it a name. This function's name is is_even, and it gets one parameter, which is an integer type. Okay, and docstring is this part, which is a comment. Think of it as a multi-line comment. It always starts with three double quotes and ends with three double quotes, and within it, whatever is written is not part of your code. It's a comment. It describes what the function does. So it's saying that the input is I, which should be a positive integer, and it returns true if I is even, otherwise it would return false. Okay. And these two lines are the body of the function, and what they are doing is very simple. It prints that I am now inside. The execution is inside the body of is even function. Okay, and it's simply returning the result of this logical operation. And the logical operation is I%2, also called I mod 2. Is it equal to 0 or not? If you remember in a previous lecture, we talked about this operation. This returns you the remainder of this division. So if I divided by 2 has a remainder of 0, that means I is a multiple of 2, which means I is even. So in that case, it would return a true value. Otherwise, it would return a false value. So it's a very simple function. If you call it with the number 3, it would return you a false value. If you call it with number 2 or 0 or 4, it would return a true value to you. Let's take a look at this example here. In our code, we have these two functions. And this is even with return and is even without return. These blue are the names of these functions. And with return, without return, the name doesn't matter. We can write any name that we want, but just for clarifying, you would notice that as part of this definition, there is no return value. And as part of this definition, we have this return statement, return remainder is equal to 0 or not. And remainder is another variable that we just defined with that statement of expression of I mod 2. Okay. If we run this, this part of code without the print statement, what we will get is, let's comment these out for now and run the file. It did nothing. It said with return, which is a print statement within this function. But we don't see any other output. Okay, that's because I did not print whatever was returned from it. And if I do that, I would get this. The first with return is when we call this function the first time on line number 14. And the second with return and the value false is a result of the execution of this function here. And then also printing what was returned from it, which was a value of false because the number was 3. If I change it to 4 the second time, I would again get with return for the first execution, with return being printed here on line number 10 as part of the second execution, and the return value itself was true because my input to the second time function was function call was 4, which is an even number. Okay. And here there is no return value. And if I try to print what was returned from it, as I mentioned earlier, if nothing is returned and we try to find out or get the value as a return value for that function, it would be none type, okay, which is a data type itself. It's not a string. It is the value is none type. Okay, let's go back to our slides. If anyone has any question while we are going through, just raise your hand. Okay. So when we talk about functions, we have to understand the concept of variable scope. It is possible that the same name of the variable is defined outside the function and is also defined again inside the function. So what happens in that case? First of all, if you here we see that we have variable x, which is in the main scope. We did a definition here. So that's just a definition. Nothing is executed yet because we have not called the function f so far. The next line that will be executed as part of this program is x is equal to 3, which defines a variable x and gives it a value of 3. And then I create another variable z, which is calling the function f with the value of x, which is 3. So when this function f is called, here we have to understand the concept of scope. So this is the global scope, and this is the function scope. Okay, I will elaborate this in the next slide a bit. So when we say f of x here, before we get assign any value to z, the whole function of whole body of x will be executed, and this x is given as a parameter, as a value to this variable x. And inside the function, we are incrementing it one time. We say x is equal to x plus 1. So if it was 3 here, 3 being passed inside this x as a parameter to the function f, it would go in here. It would become 4. And in this print statement, it would print the value 4, which we just updated over here. Okay. And then that value 4 will be returned back. And when it returns back, that value of 4 for x will be set in the variable z. Okay, so let's take a look at it once again. That page became a little bit more messy. Okay, so we defined a variable here, defined a function called f. It has a small body. It increments whatever value comes in here it is incremented once, and then we do a print statement, and then we return that updated value back to where it was called from, okay? So in our global scope, we have a function f, which is this body, okay? And then we have a variable x, okay, which is 3, and then we have a variable z, which is here, okay? Before we go into the scope of f, this is the global scope where we have the value of x, we have a function definition of f. So as soon as this is executed, the controller flow goes into this function. So it goes here, okay? And a new scope is created, which is for the function f. And inside f, there is a variable called x, which was initially given the value 3. And when we execute this statement, this 3 becomes 4. It is being incremented by 1, okay? And then it would print something, and this return statement would return this value of 4 and put it back in z here, okay? And z will, so when this return statement is executed, that scope that was here for function f, it's gone, that scope is finished, and the value, whatever was returned, is assigned into our variable z. So that's a simple explanation of how a function call works. So as I mentioned earlier, if there is no return in the body of a function, it would return a none type, and we saw its example in code just here. Okay. So none, basically, it's not a string. It means the absence of a value. Sometimes it's useful to use it as a logic operation within our programs, but it's seldom that it's useful. It would depend on how you implement your programs. Okay. So return versus print. You saw that sometimes we printed and sometimes we returned. There are different uses for both of them. A print statement would print something on the screen, and this none is coming from another print statement which was outside in the global scope, which called the function. If we print something within a program, it would be printed to the user. It would be shown to the user. But it's not something that would be returned back to the previous scope where the function was called. And if we want to do that, we have to return that value. Okay. And the return statement is a statement just inside a function, and you can only return one data type at a time. That data type itself can be holding multiple values, right? You could return an array or a tuple. We will look at those in next class. But you can only execute one return statement from within a function. There may be more than one present inside an if construct, that if something happens, then return this, otherwise return this. And if none of those happen, then lastly return this. So there could be more than one return statements within a function, but only one of them will be executed. But you can execute as many print statements within a function that you want. So whenever you execute the return statement within a function, the controller flow returns back to the previous caller, and nothing after that is executed. And as part of your logic within a function, sometimes it's useful that you reach a state where you want to return a value. There may be other logic after it, but since you found your answer or you found what you were looking for or trying to compute, you just return, because as part of your conditions, that earlier return might not execute, and you might still go to the control. You might still move your control to the statements after that. But if a return statement is executed, the function ends right there. And it always has a value that is given to the function caller. whereas as part of print, there is also a value, but it's only shown to the user as part of the output. Another concept is that you can also have functions as arguments. This is a little bit complicated problem, but I'll demonstrate as part of similarly as a diagram with scope that I showed earlier. So here we have function A that prints that I'm inside function A. Then we have function B that prints that I'm inside function B, and then it returns the same value back. And then we have another function called function C, which again prints that I'm inside function C, and then it calls the parameter as a function, which means it's expecting a function as a parameter here. If you don't pass it something which is already defined as a function, then you probably would get an error. Okay. And we will take a look at this example, how it is executed. So as part of our global scope, after definition of these three functions, what we are doing is we are printing function A. We are printing 5 plus function B with a parameter of 2. And then we are printing function C and giving function A as a parameter to it. Okay, so the overall execution will be a little bit tedious, but let's see how it works. So in global scope, what we have done is we've defined three functions, A, B, and C. Okay. Our next step would be that function A would be called as part of this print statement. And what that would do is it would print that I'm inside function A. All right. It returns nothing. Since there is no return statement here it does not return nothing, it returns none. All right. And that would come back to the global scope. Our next action would be that we have now finished this execution, and we are now executing this statement, which says 5 plus function B with a parameter of 2. And what B does is that it has a Y variable, which it will do nothing other than printing here and then returning the same value back. Okay. And which means that this part here would get a value of integer 2. And what we are trying to print here is 5 plus whatever was returned, which is 2. So 7 would be printed. Okay. So it returns 2, which becomes 7 because we are adding 5 to it. What happens after that? We will now call this function function C and give it function A as a parameter. So function C has a scope variable called Z, and it would print that I'm inside function C, and then it would return calling this parameter as a function, which would create another scope of function A because function A was provided to it as a parameter. So this statement is creating this scope here that we are looking at. Again, function A just does a print statement, doesn't return anything. This none will be returned back to Z, and Z would also return nothing. Return the same value of none that was given to back from function A to function C, and that is returned back to the global scope. So this is how this overall execution would happen. Before we move forward, let's see if we have this example here. Yeah. So same definitions, function A prints that I'm inside function A, function B prints that I'm inside function B, but returns the Y value back. Function C prints that I'm inside function C and then calls Z as a parameter, Z parameter as a function once again, which would call function A once again, and it would print I'm inside function A. Okay, so if you run this, let's see what it does. So inside function A, none is the value of this printing here. And then we are inside function B as part of this. And then 7 is the value which is being printed as part of this print statement. And then function C is called, which calls function A because that was its argument. And then prints none because A returned nothing, hence C returned nothing as well. So that last none is a result of this print statement. All right. Okay, moving on. So this concept of scope within a scope is important to understand, and as you do programming, you would have to make sure that you know which variables are visible where. Okay, so here, for example, in the global scope, we have a variable called x, but inside the function, we are defining an x as well. So this x is different than this x outside. If we call function f with a value of x, it comes in here as y. And then we have another value x, um, which is being incremented once and printed once, and then over here we print it once. Okay, what's the purpose? There's a question, the purpose of having a non-return value. As such, there is no purpose for returning none unless your logic itself has that as a requirement. When we do some problems later on, probably there would be a few examples where you would get to see why there might be a need to return none. But as such, a function is supposed to do something and then return a value. But suppose it's not able to do that computation for any specific reason, then as an error value, you could return none instead of a 0 or something else. So that would all depend on the logic of the function that you were trying to write. So as I was explaining this, this x here is different than this x because they are both in different scopes. But at the same time, if this is the definition of a new variable, but there may be scenarios where you did not define x within your function, but used it. Okay. So what this kind of scenario does is that it would try to look in the scope from where it was called. If there is an x being defined over there, it would use that within the execution. If x is not defined in the scope where it was called from, then it would result in an error. But if not, then if it is available from the previous scope, it would still be valid here, and that's that's the value which will be used over here in this print statement. Okay. But there is a third example where you have defined a variable in the previous scope, but in here you are trying to change it. Okay. X plus equal 1 is same as x is equal to x plus 1. Okay. Now here, basically you are trying to update a value for a variable which you did not define within this function, and this would result in an error. There is a way of getting around this issue, and that is to define global variables. But defining global variables is not a good programming technique, and it is very frowned upon. And the reason for that is that having global variables within your program is can be a cause for a lot of problems which are very hard to debug. You would not know where that variable is being updated, and it's visible everywhere. Many functions might be updating it. So it's not a good practice to define global variables. You should just work with the local variables, pass whatever values you need to pass to a function, pass them as parameters, get one return value, and then use it. It's also probably not a good practice to have same name of the variable being used again and again. I know X, Y, Z, I, J, K, A, B, C are easy names to write, but you should have variable names which make more sense. Now, this is another. We will take a look at another scope example, but Python Tutor is a very good resource where it has a very good kind of visual explanation of this concept of variable scopes, of where the values are coming from, where they are going, and you could try that out. The link is available in the slide that was given to you earlier. Okay, so another example. Let's say there is a function called g, and this is its body. In the global scope, we are saying x is equal to 3, and then we are calling this g function with this value of x and putting that result back into z. Okay. Now within the definition of g, you see there is another definition of another function. This h is defined as a function within the function g. So that's something that is allowed in Python. You could have, depending on how this h function is used, you might want to have it just within the definition of g. And that's where it would reside. That's where its scope is, and that's where it's visible. Okay. Okay, so we have a function g, then we have a small function h, which does not have any parameter. It just says that x is equal to abc. All right. Whereas back in g, we are saying x is equal to x plus 1. This x is what was given to it as a parameter. And then we are printing that g, we are within g, and x is equal to this value of x. Okay. And then we call h, which is just defined above it. Okay. All h does is that it assigns abc to x, and it does not return anything, does not print anything. Okay. And lastly, we are returning the value x. Okay. Now think about what value of x would be returned to z. Let's take a look at our scope analysis. So there is a global scope. We have a definition of g. Then we have an initialization of x. Then we have another variable z. Okay. What g is, it's some code, which is this body. Okay. And x has a value of 3. Okay. Now the first extra scope that we would create is of this function g. And within g scope, we have a variable called x, which is part of g. It is being given a value of 3, which is coming from this x, which is coming from this 3. Okay. So when g is called, it is called with x is equal to 3. And within g scope, we have a function called h, which is another function definition, and it has some code in it. All it does is create ABC. So before h is defined, but it's not called yet. And the first action between the previous statement, we were over here, we called g, we defined h, and the first statement that we will execute is x is equal to x plus 1. So this x would become 4. Okay. And then the next statement is printing something that would be printed, and then h would be called. When h is called, it has no variable. It will try to update x to a value of abc. Okay. And it is not returning anything. So the return value from h is none. Not ideal, but yes, it would return none, which is returned back here. And then this x, which was calculated here as part of execution of g, is returned back, which goes into the variable z. That's how this whole execution would work. It's I don't know if we have this example here. Yeah, we have it. It's a little bit different. Okay. Mhm. Okay. In g of x and x is equal to 4. That would be this print statement. We have assigned this value into z, but we haven't printed anything. If we try to print it as well, we can say print z and run it again. It would say it in g of x, x was 4, and outside in this print statement, it's 4 as well. Okay. Okay, I believe this was the end of our slides. Lastly, it's if you use the concept of decomposition of your code into modules and the concept of abstraction of what a function does, the writer would know it, but the user might not, which is completely okay. And but you should always write comments on top of your functions, the functions that you write, of what it's doing, what it is expecting as parameter, and what it is returning as a return value. So if you have the implementation of your function in one place, it can be used at many different places as part of your own code or code of others. But you only have, if there is a problem in it, you only have to debug and fix it once. You don't have to do it as many times it is being used. And that's the benefit of this decomposition, or encapsulating your functionality into functions and putting them aside. That would be the end of the lecture today. If you have any questions, you can either write in the chat or ask them. But before we finish, I would ask, you have been given 2 problem sets so far, and today is lecture 4. So we would be releasing problem set number 2 as well. But problem set 0 and 1, I hope all of you tried to do them. And if you did, it would have been very good programming practice. But I would request Hanan to just display that simple implementation of those problem sets, and show how the result works. Hanan, are you ready for that?
Yes, I'm ready.
Okay, can you speak a little bit louder and share your screen?
Okay. Can you see everything fine?
Yes.
So we're going to start with problem set 0. Here, this was asking about doing 2 things. One was raising a number to a power, and the other was taking a logarithm of a number. So we're going to start by asking the user for an input, saying, please enter number x. We're going to typecast it as an integer, and we're going to store it in this variable called x. We're going to do the same thing for y, typecast it as an integer, put it in y. And then we're going to perform an operation here, doing x to the power of y, and we're going to store it into this variable answer1. Next, we have to take the logarithm of x, and to do that, we use this function log2 from the NumPy class, which I imported NumPy at the top, and I wrote it as NP. So when I call it later on, I don't have to write NumPy, I can just write NP. So what we do here is we write np dot log2x, np dot log2 of x. We write it as an integer just in case, but we don't really need to, since the function returns it as an int anyways. We store that in answer2, and then to end off, we do 2 print statements, one saying x to the power of y equals, concatenate with answer1 as a string, and the second line is log of x equals, concatenate with answer2 as a string. So if we run this here, from the example, we can use the numbers 2 for x and 3 for y, and we get x to the power of y, or 2 to the power of 3 is 8, and the logarithm of 2 is 1.0. Now, the reason I had int here was because it returns the value as a float, but in our example, it was asking specifically for just 1 as an integer. So if we rewrite this, we get 2, 3, we get just 1. So sometimes if you're doing an assignment for school, maybe then they tend to be very strict about the way you give your outputs. So that's why we do this integer typecast here. So next we're going to look at problem set 1A. This was looking at our house hunting exercise. So they asked for a bunch of inputs from the user. They asked us to initialize some variables and then find out how many months we need to reach the amount we need to make a down payment on the house. So we're going to start with some user inputs here. First, we define annual salary as the input of enter your annual salary. We had cast it as a float. Next, we ask for a portion saved, which is the percent of your salary to save as a decimal. We also typecast that as a float. And lastly, we ask, please give a total cost as into the cost of your dream home. We also do that as a float. Next, for ourselves in the code, we define some variables. First one being current savings. We write it down as 0 for now. Then we calculate our monthly salary with the annual salary we got divided by 12 months. Next, we define the portion of the down payment as 0.25 or 25%. And we calculate the down payment amount as this portion down payment, so 0.25 multiplied by the total cost we got from the user. We also have a return on investment as 4%, and we define the number of months we're looking at as currently 0. So to solve this problem, we're going to use a while loop, and we're going to stay in the loop until we reach or exceed the amount we need, which we write down as this logic function being current savings less than down payment. So right now it's going to be false because 0 is less than the down payment we have calculated. So 0.25 times whatever cost we get, it's going to be, the current savings is going to be 0 at the beginning. So we come into the while loop. First thing we do is gather a return on our investment. And since the first month is right now 0, it's going to be 0. But for later on, when we do calculate it, it's going to be a new variable called additional current savings. And how we calculate that is we take our current savings, we multiply it by the return on investment, which is 0.04, and we divide all that by 12 months. And we store that in this variable. Next, we save a portion each month. So for example, if we save a portion saved of 10% or 0.1, we multiply that by the monthly salary that we calculated here. And we add that on to our current savings. So as we learned today, plus equal means current savings plus this amount here adds on to current savings. So current savings gets redefined by itself plus the value on this right side. And next, at the end, we add the two together. We add additional current savings to current savings, and we get the new current savings. So we do plus equal again to redefine current savings. And at the end, we increment by 1 month. We add months plus equal to 1, and we go back. And we keep going and going until current savings becomes the opposite, which means greater than or equal to the down payment. Once it becomes greater than or equal to, we leave the while loop. And then once we leave the while loop, we print the answer with number of months. Would you mind telling me the numbers we need here for our test case?
Yeah. So in our example that we showed, the annual salary is 120,000.
1,000
Um,
salary.
yeah, saving should be 0.1, 10% of every month you should be saving. And then the cost of your dream home is 1 million.
Here it's telling us we need 183 months to be able to save up.
Yeah. So run it again. The second example is that your annual salary is 80,000. And you're saving 15%, 0.15. And the cost of your dream home is 500,000.
105 months for this one.
Yeah.
Next, we can move on to problem set 1B, which is the exact same thing as A, except this time we're also asking the user to give us the value that they receive for their semi-annual raise, or the rate at which they receive a raise at. So everything else stays the same. We have a current savings, monthly salary, portion down payments, return on investments, and a month. We do the while loop again with the same statement. Current savings is less than down payment. While that is true, while this is false, we stay inside. Or not, while it's true, we stay inside. So we go in, we do our additional current savings again. We calculate our current savings based on the portion we save each month. We add these two values together to get a current savings. We increment our months by 1. But we also have to do a check to see if we've reached the 6th, 12th, 18th, or so on month. And if we have reached one of those, then we do what's inside the if statement. So the if statement here is checking if months divided by 6, the remainder of that is 0, which means it is divisible by 6. So it's the 6th, 12th, or 18th month, or so on. And we go inside the if statement. We redefine our salary with the new raise, meaning we do a multiple equals. So monthly salary times 1 plus the semi-annual raise equals the new monthly salary. And we go back to the top and we do it all again. And we keep going until our current savings becomes greater than or equal to our down payment. And we see how many months will that take. So if we run this one, values.
Okay. Yeah, your monthly salary is 120,000. Sorry, annual salary. 0.05. You're saving 5%. Cost is 500,000. And your semi-annual raise is 3%, 0.03. 142 months.
142 months. Okay. Another example is that.
Okay, thank you. The third part of this this problem set was the use of bisection search. If you remember in our last lecture, we looked at bisection search. The code for that is part of the lecture slides as well. I would encourage all of you to do this problem set 1C yourself. Okay. All right. Thank you, everyone. See you in next class. Bye.